So we looked at the Cohen's d value, but the way that most people talk about whether or not two data sets are statistically significant or statistically different is looking at a t-test. So this is on page 32 if you want to follow along. So the student t-test is looking at, is the difference significant based on how many readings you took? Because if we see a huge difference but you only did 3 readings, well, who's to know if that's actually statistically significant? Whereas if you saw a huge difference with hundreds of samples, then it's very clearly different. So the way we're going to do that, we're going to be looking at the variance of each of these divided by how many samples we have. And in this case, we actually took the same number of samples for each, so that's kind of nice. So our standard error, which is our SE, the standard error is going to be equal to the square root, which is why I'm putting in parentheses. I know at the end I have to do some sort of 0.5. And then we're going to take inside the variance of our first group divided by how many we had, which is 26, plus our variance in our second group divided by the number we had, which also happens to be 26. And in this case, we can go ahead and just do a square root. So that's our standard error. So now our t value, and this is what we're going to compare to the table that's on page 33, is going to be the absolute value. So that's our ABS again. So the absolute value of the difference of our means. So in other words, how far apart are our means? So we're taking that absolute value and then we're dividing by this standard error. So in other words, how big is the gap between our means? And how big is that gap relative to how wide our variation of data is? If our variation of data is really big, then it doesn't matter that we've got a big difference between our means because our data is super broad. So we have a 1.25. All right, why do we care about that? Well, if you go look at the table on page 133, we are going to compare that number to the number that's in the table. So our degrees of freedom that we're going to use is figured out by adding the number of data points in our two sets combined. So 26 plus 26, that's 52. Okay, minus 2 is 50. Now there's not an entry in the table for 50, but we're going to go ahead and interpolate between 40 and 60 that our critical t value is probably 2.01. So now you look at our calculated t value. So our table value is going to be 2.01. And so we look and see which one is bigger. So if the calculated t value here was bigger than the critical one, then that tells you that they are probably different. But if it's smaller, so this one is smaller, that means that we can't really say that there was a statistically significant difference between these two. In other words, those two means are close enough and there's enough overlap that we can't say that this is statistically significant. So I'm going to write this on here so you see it visually. If calculated t value is smaller than the critical value, that's the value from the table, these guys are not significantly different. So go look at those colony yields. I want you to take a look. Are the yields between 2020 and 2021 significantly different based on that t value?